Hi, Ken Goodman here. I'm going to try to make this a fairly short video about electronic prototypes and techniques I've used to build them over the years. So let's start with wire wrapping. That's not actually the first technique I used to build prototypes, but back in the 1980s, I designed and helped build a fairly complicated computer board that was built using wire wrap techniques. Unfortunately, I don't have any of those devices around to show you now, so I'll just have to settle for some borrowed photographs that I pulled off the web to show you what I'm talking about. Breadboarding was probably the first technique I actually used when I was starting to build electronic devices back in the 1970s. So this is an example of a small breadboard. I think this one is probably part of a slamometer that I was working on at some point. Here's a more complicated device. I was actually somewhat surprised to come across this in my attic the other day. This is what started all this. This is a breadboard prototype of a touchscreen that I designed back in the early 1990s. I actually built this and had it working. It used a clear plate mounted through 4 piezoelectric sensors on the corners. The raw data was, it came in through these op amps and was conditioned and then was digitized by this Texas Instruments A-to-D chip on here and transmitted to an IBM PC through a RS-232 port. And then there was software running on the PC that I wrote to actually detect touch events on that clear plate in front of the PC monitor. These breadboards, typically they have rows of holes with contacts behind them. Wow, look. Archer. Radio Shack. These breadboards have rows of metal contacts in them. You connect devices together by putting a component lead in one of the holes along a row of common contacts. This is like a power bus, the other power bus, and then small rows for different nodes, different electrical nodes. If you put 2 leads into holes along this row, they'll be connected together through these metal strips in the back. Oh, it's only a finger. Okay, here's one of the contact strips out of that small breadboard I was showing you. They're spring contacts. The plastic body of the breadboard has kind of a funnel shape that guides wires into the right part of the contact. The spring contacts grip the wire. Any wire that I put in here at one point is connected to the other wires in the same strip. This is obviously not a technique you would use to build something that you meant to be very durable. Let's move on to point-to-point wiring. This is a simple piece of test equipment I built to use with a product I designed and was manufacturing back in the 1990s. And the components here are inserted in a vector board with single-sided pad per hole board. This is pretty convenient for building through-hole prototypes. Generally, you'll arrange components with leads that are supposed to be connected together, physically close together. Leads going through holes in the board, and then leads bent together and soldered on the back side. There'll also be a lot of jumper wires connecting components or leads that are not so close together. If you have a lot of those jumper wires, you can put them on the back side of the board behind components. But this was a fairly simple circuit, so most of the jumpers are just on the top side of the board. Here's another little gizmo that I built a prototype of back in the 1990s that uses through-hole components and point-to-point soldering. This one is a little toy that I made one of for my wife. This is actually a persistence of vision device. Let's see if I can get it to show up well with the camera here. Right now it's showing a smiley face. There is a connector on the back, so you can connect it to an IBM PC. This is a program I wrote that lets you draw simple images. I think I just used bitmaps produced by Microsoft Paint, if I remember right. And there's a power switch on the side, which also doubles as the activation switch. And let's take this apart, see what's inside. You can see there's a piece of vector board there. Through-hole components, point-to-point soldering, and then everything is held in place with hot melt glue inside the enclosure. The LEDs on the front are just held in place with hot melt glue inside the box and connected to the main board with a ribbon cable that's terminated here. Current limiting resistors for the LEDs, a little PIC microcontroller chip, and I don't even remember what that is. Oh, that's actually a serial A² prom that holds the image data. This battery's been in there several years now. The circuit is completely dead, drawing zero current from the battery when the switch is not closed. Okay, let's move on to hand-etched circuit boards. I hand-etched a few boards in my time, but I don't have any of those in my attic or junk stores, so I'll just have to settle for showing you a borrowed image of somebody else's hand-etched board for now. My hand-etched boards worked okay, but they were very messy. That's a very messy process. I really didn't care for it.
Nowadays, it's really easy and inexpensive to have somebody else make some very nice professional circuit boards for you, like these examples. Here's a through-hole device I built with a circuit board that I ordered from Osh Park online. That's one of several companies that do business this way, that produce small volume custom circuit boards for hobbyists and professionals alike. Even in this day and age, it is easier to build circuits using through-hole boards and components than using surface mount, but of course everything is bigger, it takes more space. A lot of components are not available in through-hole versions these days. So nowadays I'm doing a lot more surface mount. So I'm going to show you how I typically solder surface mount boards here these days. I've got a little fixture put together here to hold the board in place. I've got a stainless steel stencil that I've arranged to fit down over the board. It's lined up with the pads on the board so that the openings match those pads. Squeegee solder across the board. Now the surface mount pads have little blobs of solder on them, which I'll show you under a microscope later. Then I'm going to place components by hand, one at a time. So we're going to transfer the board over to a hot plate, which I have heated up to hopefully a little above the peak process temperature for that solder. I've got the camera looking through my microscope that I often use working on these boards with really small components. These are not especially small, but they're small to me. Put the stencil down in place. You can see the holes in the stencil line up fairly well with the pads on the board. I'm going to make sure I've got plenty of solder paste for the next couple of boards. Let's squeegee it across. See how that solder looks on those pads under the microscope. You can see there's a nice blob of solder on each pad. While that solder paste is still wet, I'm going to place components one at a time by hand. Oops, if I'm not able to look through the microscope while I do this since I've got the camera in the way. So I missed that one pretty badly. So I'm having trouble doing that without the microscope, so I'm going to move the camera out of my way. So I've placed all the components on this board. Smeared the solder in a couple of places, which is typical for me. Good thing I'm not a surgeon, right? You can use a good pair of tweezers for placing these parts, but for small components it's a lot easier to pick them up with a vacuum tool like this one. This is a Hacko vacuum pickup tool for manual use. That's what I usually use for placing the small components, and then I use the tweezers to place components that are a little too heavy for the pickup tool.
We're going to take this board over to the hot plate. Here's the hot plate I'm using. Set point is 250 Celsius, which is as high as it goes on this model. That's just barely enough to solder these lead-free boards with standard solder. I'll just slide that board off onto the hot plate. I'll watch the solder joints get shiny, and once it looks like they're all melted, I will move that board off to cool. Okay, so let's put that board I just soldered under the microscope and see how we did. Those solder joints look okay. There's a couple of solder balls which I'll probably remove by hand. I think I tend to get a lot of solder balls when I do this because I'm smearing the solder paste when I place the components. So that's a look at the techniques I've used to build electronic prototypes over the years, from the 1990s and before up to the present day. Maybe some of you will find that useful. If not, at least I had fun making this video. See you again. Good day.